Recording. You're recording. Okay, so the first thing that I'm going to do here, welcome to class, everyone, is I'm going to download this data because I might use it for some examples. So I downloaded the data in the lab. Lab 3's data is right here. Just as a review, what type of data is that? Okay. Yeah, it's a geodatabase. Definitely a geodatabase. Let's see, I'm going to put it somewhere. Let's start up Arc Pro. Should have done that already too. But the geodatabase is a newer file format than the shapefile. The actual structure, the way that the data is organized is very similar to a shapefile, but it's a totally different format. But in terms of how the features are stored, like so let's say we were storing a layer of counties. Is there any area in the country that's not inside of a county?
Louisiana.
Well, okay, you're in a parish, but a county level entity. There are a few exceptions. I think in Virginia, when a city incorporates, they actually become their own entity outside of the county. I'm not exactly sure how that works, but it seems to be. But for the most part, in most states, the counties are totally contiguous. Another thing that's like this is a census tract. Everywhere that you can go in the United States, you're in a census tract, right? So there are actually a fair bit of layers like that. Sometimes in some applications they call this type of layer a fabric, where any boundary is actually a common boundary between the polygon next to it and the polygon you're in. So you see how that could be different than, like, let's say I had a layer that represented lakes, right? The boundary around a lake represents the edge of the lake, and when you're in the lake, you're in the lake, but when you're out of the lake, you're out of the lake. So when you store a polygon that represents a lake, it's okay to just store the edge of the lake as the feature, and then everything is inside of the lake. Now you can use that same data structure when you store a county, but you're double storing, like let's for here, the boundary between which one's Jackson County?
The one all the way on the right.
The one all the way on the right. So Jackson and Harrison County border. Mm-hmm. So you're double storing that line between Jackson and Harrison County. And for y'all up there, you're double storing the line between Forest and Lamar County. See what I'm saying? That if you store them like you would a lake, you're storing the polygon for Forest and the polygon for Lamar. Well, what happens if you change the boundary between the counties? How many polygons do you have to edit in that case? Yeah, you have to edit 2 polygons. And so I guess the whole thing I'm trying to get at here is that both a shapefile and a geodatabase share that kind of a storage feature where they don't have a separate way to store these fabric type layers. And so they all have to come as editing tools. So there are editing tools where you can go in and say, do any of my polygons overlap? Or are there any gaps in my polygon area? And they'll show those to you and you can change them. Okay. That's different than some older formats that are still in use, like the what they call the Arc Info format. The Arc Info format, you draw all the lines and then you tell it to build polygons from lines. And so it's great for storing things like county boundaries or census tract boundaries. It was built to store those, what they call topological relationships. So when you change the border, it's just one command to say rebuild all the polygons, and the polygons are rebuilt from the borders. And parcels are kind of like this too in the United States, right? Like all the land is owned by somebody, whether or not it's the federal government or an individual private property owner. All the land is owned, and so when counties and local municipalities store their parcels, they want to be able to store them in fabric type layers, whether that's handled afterwards or beforehand. So anyway, that's I just got on that topic when you mentioned shapefiles. They are very, very similar to shapefiles. So I'm going to create a new project in my ArcGIS Pro projects, and I'm going to call this. I'll just call it Lab 3, and then we can build off of it for Lab 3. Although some of these will be examples that aren't necessarily part of the lab. So that was in Documents. Forgot to look at the path. Documents, ArcGIS, Projects, Lab 3. Okay. So I'm just gonna take this Lab 3 folder that's there and delete it. Let's see if it'll let me do it. Yep. And then paste in my Lab 3 data folder. So now when I'm doing that in that manner, what I've done is under databases, I have this Lab 3 folder that has a number of data sets already in it.
So you do that not in ArcMap, but through like your documents folder.
I just did that in Windows, yeah. Yep, in the Windows Explorer. Now, if you didn't do it that way, you could put it somewhere else and still access it by right-clicking and saying Add Database and navigating to that GDB folder. So a file geodatabase in ArcGIS, it is a folder. Like that's how the ESRI coders have created that entity on disk. So it is just a folder. It has a special name. It's named whatever you name it, .gdb. So usually files have extensions, right? But in this case, a folder has an extension, .gdb. All right, so I've put a number of different data sets in here. I have, the National Park Service lands here. Okay, so there's National Park Service lands. I have all of the Major League Baseball. Current Major League Baseball teams, like their stadiums. I've got large cities. I've got a few different layers to play with. The ones that we'll be using in the lab, I'll go ahead and turn these off for a second. But the data sets that we'll be using in the lab are actually this tornadoes layer. So there's a tornado. So that's all the tornadoes from a certain time period. Let's look at the attribute table. It's from like 1953 all the way until 2017. I could probably download a more recent version, but that's what I have there. And then we've got the U.S. counties right here. So we've got tornadoes and counties, and those will be the two layers we use. Plus, we're going to make another layer. All right. So let's talk about what we're going to talk about today, and that is we're going to talk specifically about the concept of joining. So I have to review a little bit of table terminology real quick. I already downloaded. There it is. And I wanted to go in, and some of these screenshots are like old-timey screenshots, but I need to change those, update them to ArcGIS Pro. But I think I'm just going to leave it like that. There we go. All right. So we're going to talk about join operations and proximity, and you might think that those two topics aren't related, but they are, and you'll see that in a second here. All right, and they're related because of this this concept, which I'm going to call spatial relationships. So, in order to join two different attribute tables spatially, we need to talk about what a spatial relationship is. And so we have lots of different spatial relationships, and the spatial relationships are basically how two different objects or how several objects are related to each other in terms of their position, their latitude and longitude, or their coordinate in a projected coordinate system. So one of the keys here is that when we're trying to answer GIS type questions or questions that we can answer with our GIS, it's often important to determine and quantify the spatial relationship. And so there are a lot of different tools that exist in GIS software to look at spatial relationships. And so sometimes you have a bunch of choices, and it's important to understand what each choice means before you go and answer your question. And sometimes you have to read through the help because the words might change slightly over time, and you have to know what does this particular spatial relationship type that this particular software vendor has created, and is it exactly what I want? We talked the very first week about the concept of the very first week about the concept of sorry, what was the term? Adjacency. Okay, so adjacency is another way to discover or to talk about spatial relationship. What defines what's adjacent? That's really what I'm getting at here. Is when I look at two objects, are they nearby each other, or are they touching, or are they touching in a certain way? Those are the spatial relationships that we're going to discuss, talk about today. So sometimes we break these down into not just adjacency but proximity. So the basic question: are items connected? So that's one thing we'll be talking about when we talk about joining or connecting two different spatial entities. We're going to say, are they close to each other? How close together? If they're really close together, or are they far apart? How are we going to establish a spatial relationship? Well, you get to decide for a particular question how you define that. Okay. So adjacency is, are they immediately next to each other? Do they share a border? What type of border? Do they share just a one-dimensional border? Or do they share a two-dimensional border? Or do they just meet at a point? In other words, they share a border. They share a point. They share a zero-dimension border. And then also, do they overlap with each other? That's in an intersection. Do they touch? Do they share a? Do they share some of the same space? That's an intersection. And then another thing we could ask is, are they within? Are they contained by another layer, or another feature in another layer? There's one inside of the other. So it's another type of spatial relationship. Okay. So here's some operations examples that could be thought of as proximity operations. So we might be concerned with how close something is to a landfill, in this case a well. We might be wondering if roads pass within a certain distance of a stream, because we're concerned about runoff. Just what's the distance between two locations? And there are tools for discovering these relationships in ArcGIS. One of the tools is just called the near tool. Anybody ever run the near tool? All right. So inside the toolbox, whoops. ARC toolbox, not just the generic toolbox. That's under analysis. Tools. The near tool. Let's read about the near tool. If it ever comes up here. All right. Oh. So the near tool calculates the distance and additional proximity information between the input features and the closest feature in another layer. So in your output table, you get a distance to the nearest feature in another layer. So you could use that to calculate like you could find all your streams. You could have a layer of streams and a layer of roads, and then you could run near on that, and then you would know how close the nearest road is to every single one of your streams. It'll actually also pull in which stream it is if you want that information, and even what angle it is and things like that. So that's an example of a proximity operation that you may not have heard of. What's another proximity operation that we all have used? Like, let's say I just wanted to find out, let's say I wanted to ask that question, do any roads pass within 100 meters of a stream? Does anybody have an alternative way to answer that besides using the near tool that you might have used last semester?
We used the buffer tool, huh?
Right, you could buffer. So what would you do? Buffer which layer?
Buffer the roads and see if the stream touches it.
Yep. So buffer the roads, and then you could select by location, or you could do an intersect. Exactly. So I guess one of the points that I'm trying to get at is that there's oftentimes several different tools that you could use. The real important thing is being able to figure out what spatial relationship you're trying to get at to answer the question, and that would work. Okay. So what's the different distance between each feature layer in a layer and the features in another layer? That's definitely a near tool. What is the shortest street network route from one location to another? Right? And that is proximity. We're going to cover network analysis, but a little later in the course. Today we're going to talk about mostly straight line distance. So here are a few proximity operations. I already discussed near. You already know about buffer. All right. Create Thiessen polygons. Why don't you all read that? And how could you use that to find out the how could you use that to to find out what the closest point feature was in any particular area? Here. So what does that do? The create Thiessen polygons from point features. Well, basically what it does is it creates a fabric data set. So it creates a data set where polygons exist everywhere in the study area, and every polygon represents the area in which that particular point is the closest to that region. I'll show you here. So this is an illustration. So we've got our original points, and the output polygons represent the areas that are closest to all the input features. So in other words, if you're right here inside this polygon, you're closest to this point. Okay, so going back to my question, I'll ask it better this time because I did a pretty bad job last time. What's an application for this type of thing? Like what's a question that you might be able to answer once you had the Thiessen polygons created from a bunch of points?
How close somebody is to a grocery store? Or which grocery store they're closest to?
Yes, which grocery store they're closest to. Yeah, and it doesn't necessarily answer that question how close they are, but it does answer the question which one they're closest to. Okay. All right. Let's see here. Okay. So let's actually run one of the. I'm going to run the near tool just as an example here. All right. I grew up in say I'm not really a big. I mean, I watch some sports, but I'm not like a sports nut or anything. But I grew up in St. Louis, and at the time in the '80s, it was like that was like baseball. Like I grew up playing baseball all the time. So I've got all these Major League Baseball points, right? And I'm going to run the near tool, and I'm going to show you like one particular application of this. So we got all the counties in the United States, and I'm going to run the near tool on all the Major League Baseball teams. And so what it's going to do is tell me how far away the closest Major League Baseball stadium is to every county. Now this isn't like along a drive path, because we don't have drive paths. It's just as the crow flies, what is the closest Major League Baseball stadium to every single county. So this is how I'd run that if I was interested in this particular question. So I would specify my input features as the features that are going to get the distance attribute. So in this case, I would specify the U.S. counties. And then I'm going to specify the near features to be the Major League Baseball points. Okay. And if I leave search radius empty, it's just going to go out and do the nearest one no matter what. However, if I specify a search radius, what it's going to do is it's only going to provide me information if it's within a search radius. So in other words, if I entered 10,000 meters, which is what? How many kilometers? Yeah, 10 kilometers. Then it's only going to give me near information if there's a Major League Baseball stadium within 10 kilometers. So not everything's going to get attributes. So I'm going to leave this blank. And then something that they introduced here just a few years ago now, I forgot exactly when, but they actually calculate the distance based on planar coordinates or geodesic coordinates. And if you read the help on that, the planar coordinates means that they use the coordinate system on the map. Okay? And geodesic means that they calculate the distance along the globe to every feature. So it involves a little bit more calculation, but theoretically it'd be more accurate. Now it still doesn't like follow the ridge lines of the mountains or anything. So out west, you're actually going up some pretty good mountains, and then you're going down, and then you're going back up some other mountains, and then back up and back down all over the place. But it would be more accurate. I'm going to go ahead and select. I'm a little worried about the extra time, but I'm going to select geodesic and see what happens. All right. All right. Let's look at the help here because it's not asking for any output. So let's see what it does. Following fields. So the following fields will be added to the input. So the fields are just going to be added to this data set, so we don't need to worry about having an output data set. So that could or could not be important. Like let's say you were working in an enterprise environment, this layer was something that other people used, this counties layer. You might not want to update that. So be aware that there are some tools that actually make changes to the original data. So if you don't want that, you should definitely make a copy before editing. But I'm not worried about that here, so I'm going to hit run, and it did run pretty quick. I was a little worried about that. Okay, so now that it's done, I can open the attribute table, and I should have some new attributes here. So here's the near distance. So that's the distance, in this case in meters, to the nearest Major League Baseball stadium. So one thing that we could do is symbolize this. So in ArcGIS, you can double click on it, then click on the symbol, and then go to, actually you have to press back, then change the symbology to graduated colors, and I'm going to choose the near distance. Okay. So we've kind of created a map of Major League Baseball deserts, or Major League Baseball areas where you have to travel a long distance. So my grandpa grew up here in southern Idaho, and he was a Boston Red Sox fan. And I said, why were you a Boston Red Sox fan, Grandpa, one time? And he said, well, we could get they put their games on radio out here, so we listened to them, and I guess we became Boston Red Sox fans that way. So I guess when you're that far away, back then especially, there wasn't even a team here or here, but you can see this area is still pretty far away. So that's what that's doing. Okay, see areas that are far away from features. You could do this with a more practical problem. Now, what if we wanted to just say what's the closest Major League Baseball team to a particular area? That also got answered. And here is the near FID, and we'll switch this from classes to unique value. Sorry, graduated coverage to unique values, and choose near FID. Okay. So this shows a map of the closest Major League Baseball team. So if you were wondering what the closest Major League Baseball team is to some of these counties up on the border, whether or not it's Seattle or whether or not it's Denver, then it is Denver. So anyway, that's that question. I wonder what this is kind of interesting, that the closest team to Los Angeles kind of goes up. That's still, Los Angeles is still the closest point to some point on that county. That county looks like backwards Utah. Lincoln County, Nevada. There's like that point right there is still closest to Los Angeles, the Los Angeles Dodgers.
It looks different on mine.
What does?
Like the one you're pointing at is actually colored differently on mine.
Well,
I like the natural color, but I mean like what's selected by distance is different.
Oh, okay. Did you drop, when you dropped down? Did you do planar or geodesic?
Let's see. On which one?
When you ran geoprocessing right here, this drop down, the method. You can get to it. One of the cool things is you can always get to your history.
I went to geodesic.
Oh, okay. Yeah, I'm not sure why. I mean, that's interesting that particular county got a different value on your data. It's not closest to Los Angeles. Yeah, I'd have to look a little bit further to see why that occurred. But that's an example of the near tool. Really quickly, we could run the create decent polygons on just the Major League Baseball points, and we get a similar set of data. So this is actually going to create an output data set. So I run that. So now, if I symbolize this by the Major League Baseball team, sorry, symbology, unique values, team, go. So you can see that that layer has a similar shape to the layer underneath it, okay? But they're organized by county. So if it's basically the closest the closest Major League Baseball team to each county versus just a layer that represents the polygons, where everything inside of this polygon is closest to, in this case, the Florida Marlins. Everything in this one is closest to the Tampa Bay Rays, and so on. So from here, we can answer all sorts of questions like how many people fall within each of these groups, right? Like that might be a valid question, an interesting question. So if we consider these areas to be the influence areas of each of these teams, how many people do each one have, and do they have an equal or a roughly equal number of potential fans, I guess is what I'm trying to say, a number of potential fans. How could we do that using some of the logic that we did last week? Like, what tool could we run to get that information? If we wanted to basically take each of these areas that are really counties, and if we look, let's look at the teams here, the counties data, and we do have a layer. I mean, sorry, not a layer. Oh man. I did not include a population. I thought I did. Okay, let's say we had a column here, so we won't actually do it, but let's say we had a column that represented population. Okay, in that data set. What tool could we run, or maybe not even what tool? How could we take this information once we had a column that represented population and summarize that data and get the answer? How many people are within each of these polygons in these counties? There's a tool that we just used last week that we could use. All right. Well, I'll just give you a hint. Or what if we ran a dissolve? So I'll run the dissolve here. What if we ran a dissolve and we used this U.S. counties layer that now has the attributes? What field would we want to dissolve on to get the right answer here? Like, think about what dissolve does. What field do we want to, if we want to find the total population, since we don't have population, let's do the total area of each of the influence areas of each of the Major League Baseball teams.
You want to dissolve the counties, but you want to dissolve it by the near, like how close it is, like to the near FID, right?
Yes, we want to use the near FID. So that'll dissolve the common boundaries between anything that has the same near FID. See what I'm saying? So this will become all one polygon, right? Now, how do we get the answer that we want in terms of getting the total area for that polygon?
Would you do a union of shape area?
We wouldn't need to do a union at all. We can do it all as part of this dissolve. The later this part right here can help us to do that.
You want to sum up all the area.
Yes, we want to do area, and we want to do sum. So that will give us the sum of those areas. So if we had population, which we don't, but if we had population, then we could do also sum, and that would give us the total population. That'd be a little more interesting.
That would insert a field into your county or into the new layer. That's the field they would carry.
Right.
Essentially, okay.
They'll be named sum underscore shape area and sum underscore pop. Of course, pop doesn't exist, so we have to delete it. But well, we could do that.
If you got another county saying, and you just would join them, and then you could have pop, right? The population.
Yes, if I had a table. So here's after it runs. So now I can, if I had a table that represented population, I can do a join. Right. So now I've got the sum of the shape area. Now ArcGIS automatically calculates the shape area for geodatabases. So we didn't really have to do that, but I did it. And now you can actually see that it worked. And we could sort this by shape area and find out that number 5 here, Denver, has the largest area. Definitely not going to have the largest population served because that area is largely empty, right? But that's the largest area, so we could answer the question in that manner. All right. So, edit course selection. All right, so that's a demonstration of using something that we talked about this week, which was the proximity tool near, and doing that with a dissolve, which we talked about last week. Okay, to answer a question. Okay, so. Oh yeah, so we've also got this one we didn't talk about yet. Polygon neighbors creates a table with statistics based on polygon contiguity. I don't necessarily need to demonstrate this one, but polygon neighbors, it's a tool here. So it'll tell you for a particular polygon which neighbors that polygon has, and it also gives you the area of all the overlaps and the length of coincident edges, the edge neighbors, the number of times boundaries cross or touch a point if it's a point data set. So that's another proximity tool that exists. And you can see that all these in ArcGIS, they're all in this proximity toolbox. So that's where I got this from. But the tools are arranged by, if I go back to just the list of toolboxes, how do I do that? Oh, there we go. There is a proximity toolbox. It's under analysis, of course. Analysis, proximity. So we've covered buffer, last year you got create these in polygons, near table, polygon neighbors. Okay. By the way, anybody know what this little icon means next to the multiple ring buffer? So that means that particular tool is a script tool. So even though it's a tool that's cooked into ArcGIS, there's still a Python script that's running when you execute that tool. So one of the classes that we teach here is in Python scripting. Basically, this is an example of a script that runs a tool multiple times. So it runs the buffer tool over and over and over, so you get multiple ring buffers. So you might be able to answer the question, how much is within 5, 10, 20, 30 miles with multiple ring buffer? Because you can do multiple rings in your buffer.
In reality, you could just run the buffer yourself a bunch of times.
Yes. Right. Yep. In fact, yeah, definitely. You could even go in and look at if on tools that are script tools. When you hit edit, the script opens up. So here's the script, the Python script that runs when you run this tool. You can see it's not too long. I mean, there's a little bit that's just comments, and then it runs. Basically, there's a loop, a while statement inside of there that runs a bunch of times. Okay. All right. So here we're getting into the older screenshots. So we covered buffers pretty well. Probably in other classes. One thing to keep in mind is that when you do buffers, in formats like the shapefile and in formats like the geodatabase, you have this option right here. You can either do what we call dissolved buffers, which actually piles buffers on top of buffers. And so you have to keep that in mind when you're actually running the tool, is that you're creating multiple polygons on top of each other. And so if you were to create buffers, like let's say around roads in this example up here, the top example, and then you were to ask the question, what is the total area that is within, let's say these buffers represent 5 miles of roads. If you said, what's the total area within 5 miles of a road, you would not get the correct answer here, because like this polygon is on top of the polygon that represents this line and the polygon that represents that line. So you'd be double and triple counting, quadruple counting in some cases areas. Okay? So you really have to think about the question that you're asking in order to create the buffers the correct way. If you're answering the question kind of like we just got at before, if you're going to use this layer to then identify which streams are close to roads, it wouldn't matter if you did this one. In fact, you might want to know which roads are within 1,000 meters, and so you'd want this because then there would be a one-to-many relationship. Each stream, well, maybe even a many-to-many relationship, each stream would have many polygon buffers that it could intersect. So you would know, oh, this is close to 5 roads, or this is close to 3 different roads, or this is closest to one road. Okay? However, if you want to answer the question, how much area is within 5 miles of roads, then you would need to do this, to dissolve your buffers. And when you actually run the buffer tool, you have this option to dissolve, no dissolve, or to dissolve all outputs into a single feature, or dissolve features using the unique fields. You have 2 different ways to dissolve. This bottom one here is dissolve all fields into a single feature. Okay. So depending on the answer to the question, you have to change this. All right, now we're going to talk a bit about join operations, because there is a way to do what's called a spatial join, and it's basically a spatial relationship operation that relies on both proximity and adjacency. So when you do a spatial join, you have to specify the spatial relationship that you're trying to capture. So we're going to talk about spatial relationships, but even before that, we're going to review what a join is, because a spatial join is just a spatial type of join. Okay. So when we do a join operation, we have 2 tables that we're concerned with. And we combine those two tables based on what we call a common field. Another way to say this is if the value in this field and the value in this field are the same, make a single record for that relationship. So what we're saying is if we've got two different values that are the same, combine them into one record in the output table. So oftentimes we think about there being a source table and a destination table. And depending on how it's done, the software can actually take the source table and put the records, combine the records into the destination table, or there are tools for taking the source table and the destination table and combining them into a new output table. So in ArcGIS, both of those exist. So if we look at the tools called join, okay, we've got this join field tool, and that takes the join field tool takes the contents of one table to another table based on a common attribute field. The input table is updated to contain the fields from the join table. So in that one, the source table is combined with the destination table. The destination table is updated with the source table information. Okay. Now there's another tool in ArcGIS, and other software have the same concept, where we have a add join, I think is what it's called. No. Output join field. Join feature. Add join. Joins a layer to another layer. Okay. Yeah. I do change these names a bit. Yeah. So join field joins the contents. The input table is updated to contain. You can select which fields join. Okay, that's fine. The join is temporary, so that's definitely the temporary one. I guess join field is actually the one that that outputs a new table, and add join is the one that does the temporary updating of the data sets.
Unless you save it, right?
Yeah, unless you save it as a new layer. Yep, that's true. Just kind of like the select from last week. Okay, I guess I left that on there. This doesn't need to be there. So, yeah, joins are usually temporary relationships used by relational database management systems. So, there are two different joins. So there's a tool that creates a new data set based on join. So oftentimes that gets used a lot in Model Builder because you want to create a new data set, a new output. So tables have to share a common field. Sometimes that common field is referred to as the key. So in this case, FIPS would be the key. Key is a general term, though, and sometimes you have multiple keys in a table for joining with different types of data. So you might have a key that represents the county code, and you might have a key that represents the parcel code, and a key that represents some other code, and for joining for different tables. So once you do a join, it treats the two tables as a single table, And if you're doing a virtual join, like the add join tool, the original data is not affected, and you can remove it when it's not needed any longer. So add join is the tool that creates a temporary virtual table. And join field is the one that makes the join persistent in the layer or table. So it actually updates the join table with the new information. So I had it in my slides. Yeah. All right, we can have a few different types of joins. One is that we have one-to-one joins. In other words, in the destination table, the table getting the information, there is only one row for each value, and the source table also has only one row that has each value. So in other words, there's a Washington and a Washington and I almost said Minnesota, a Montana and a Montana, and so on. So sometimes we refer to that as the cardinality. And we'll have these same concepts when we talk about spatial joins here in a second. Yeah. So cardinality is used in set mathematics, and it's a measure of the number of elements in the set. Okay. When we say that there's a relationship, a one-to-one relationship, there's one in this set and one in this set that will match. So there's not two Washingtons or two Montanas in this table. That would be a different type of join. So here's all the different types of joins. So if we joined a table of all the states, a GIS table of all the states, to another table that contained the governors and information about the governors, there would be maybe the age of the governor, the salary of the governor of every state. We wanted to somehow join those together so we can make a map of the salaries of the governor, a choropleth map of salaries, high salaries and low salaries of every governor, maybe. There would probably be a one-to-one relationship. That's if we only included present governors, right? Like if we had a table that had all of the past governors, there would be a one-to-many relationship. Okay. So a one-to-many relationship might be states to cities. Are there more than one city in every state? Yes. So that's going to be a one-to-many relationship. In fact, I said, are there more than one city in every state? That doesn't actually really matter. The cardinality would still be one-to-many, even if there were states that only had one city or 0 cities. As long as there was the potential to have more than one city in a state, the cardinality would be one-to-many, right? Districts to schools. Most districts have more than one school, but not necessarily all. There's just Mississippi, I know there's a few districts that have a single school associated with them. All right. Now, both of these are much more common in what we're going to do as GIS in the GIS world, but they also exist many to one. So we could join the cities to states. That would be the possibility of many cities existing in a state where we take all the cities and we're joining the state information to the cities. And actually that gets done a lot too, right? Schools, districts, yeah, that we could do those types of joins. Particularly, these two get done a lot in spatial joins. These two right here.
So many to one would be like if you had all the cities in Mississippi, but you wanted to put in the city's database that the abbreviation of Mississippi.
Yeah, some attribute that was only in the state's data set.
Okay.
Yeah, you wanted to pull. So the thing on the left, the first thing on the list, is the thing that's receiving the attributes from the entity on the right. So if we wanted to add some state attributes to cities, it would be a many-to-one relationship. And because every city, it's actually not true everywhere, right? I mean, there are places in the world, but not in the United States. Cities get their charters from the state. So a city only exists inside of a state. And so anyway, I guess what I'm trying to say is that a city is always in exactly one state. Right? There are cities with the same name, like Kansas City, Missouri, and Kansas City, Kansas, the touch, but they're not technically the same city. They have a different city government and stuff like that.
Schools to counties.
Yeah, so schools to counties would be many to one because there are the potential for many schools within a county. Yep, exactly. And then many to many would be students to classes, because see how most of these are non-spatial examples, because this is actually harder to conceptualize spatially. It is possible, but and there are some examples. Let's see if I can think of an example. If we were to join things by proximity and say, show me all of the I want to join all of the schools to all of the cities, but the spatial relationship I want to use is within 10 miles. Then there would be some many-to-many relationships, because some schools would be 10 miles from city A and also 10 miles from city B, and they would be joined both. What type of question, though, would you want to answer with that? Because you'd be double counting some schools in those cases, right? Like, so it wouldn't necessarily be. I just don't see as many applications for it, but there definitely are cases where you can do a many-to-many relationship, but
Well, I mean, when the city and the school have already been some kind of attribute table, the only thing left is trying to connect the student classes to any class in the state, but you already have all those backgrounds. So you won't be doing too much of this. It might come a time when you have to just line all the students up, but maybe all of the classes in Mississippi that teach this particular subject. And therefore you can just quantify who's in what particular class and what particular city.
yeah. Well, in this example, we're talking about students taking classes. So you're taking multiple classes here. And so if we were to join the students to the classes that they're taking, there'd be many. You're one student. You'd be taking many classes.
Just one class of many students.
Right. Yeah.
Would you use many to many in a situation like if you're buying a house and you want to compare the multiple options to the multiple school districts your people go to?
Well, yeah, potential buyers to houses would be a many-to-many relationship. But again, I guess that's not. I mean, you could say, potential buyers. Where are they spatially located? Right?
Well, I'm saying like some people buy houses based off of where their kids are going to go to school. So I was saying like if you had multiple schools in the area and you want to make sure your house options were within that range, you compare all those different houses to all those different schools.
Yes. Yeah. Yep. I was just saying that the buyers in that situation may not necessarily be a spatial table, but
I got you.
In all these cases, let's think for a second about how many output rows you're going to get. So when you do a one-to-one spatial or this is just a join, whether it's spatial or not spatial. When you do a one-to-one join, the output table will always have the same number of rows as the left table, the destination table. So in this case, if you were to join states to governors, you're always going to have the number of states. That's going to be the number of rows in your output table. Okay. Now it is possible that like somebody left a governor out of the other table. Well, after you do the join, you'll just have a blank record. Yeah, exactly. Okay. Now, if we do a one-to-many, you're still, when you do that join, you're still only going to have the same number as you had in the left side of the table, the destination on the left. So you're going to have 50, but we have to think about, if we join states to cities, we have to think about how we're going to handle the fact that there could be multiple cities being joined to a single state, because we're trying to get the attributes of the cities into the state, but there's always going to only be the number of rows in the left side of the table.
So all states don't have the same number of cities, so you're trying to link up with 50 states, how many cities gonna be in that state, but is this looking like on an attribute table, you're looking across two seeing? Because sometimes there's blank data there.
Sometimes there's blank data, but that blank data would mean that there was no cities in that state. Okay? So what happens in a one-to-many join when we join cities to states? If there are multiple cities, we have to specify something, and that is how we are going to collapse the attributes of the cities down into one entity.
Cities have a count, like there's
Yeah,
seven cities.
exactly. So we can use a one-to-many join to say, okay, I'm going to take all the cities, I'm going to take all of their I could do the count. I could just say, okay, I'm going to do a one-to-many join to find out how many cities are in every state.
Okay.
And so every row will have a state, and then there'll be a count of how many cities there are. And that's a one-to-many join. I'm using the statistic count. I may want to find out how many. I may want to find out what's the total population of all the cities in the state. Because that's different than the total population of the state, right? Like, there are people that live out in the country, out in a rural area. So then I could do a join and use. I could aggregate the population of the cities before I do as I'm doing the join.
So to do a one-to-many, you have to do some kind of stats to condense it. So
it's kind of like doing a dissolve.
Average or something like that.
Yeah, it's kind of like doing a dissolve. Well, you don't have to, but you won't get any good information if you don't do the. Yeah, so just think of it as you have to do that to do that. Okay, a many to one. Think about the left table being all the cities, and they're going to get the attributes of the states. Now, the way that is handled is that you get repeat rows. So if you have a city, it'll have as many attributes of the states as you want to put in. And then if you have another city that's in the same state, it'll also have those same attributes. Okay? So you get repeat rows.
So like if there's 3 cities in Mississippi, you'll have an MS if you're...
Right. So yeah, if you have 3 cities in one state, you have postal code as one of the attributes, you'll have MS. Three representations of that. Okay. And then finally, with many to many, if we were going to do you're still going to have to aggregate the input data set to get it to work out right. All right. So here is a diagram of that real quick. So if we're going to do one-to-one, we can just line them up. This row will get all the attributes in this row. If we're going to do many to one, the destination table is going to get a bunch of different records from this table, and they would need to be. Oh, sorry, this is many to one. So this is this is the second example we were talking about before. We get the repeats: Washington, 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 Washington. So that's an example of this one. Okay. This is the one that needs to have an aggregation. This is the one where we just get repeats, like this. So one to many. The destination table, it violates the rule of joining. Okay, it's ambiguous. Which record is going to get which of these is going to is this one going to get this record? Which of these records is it going to get? Well, we have to think about the question that we're asking and aggregate accordingly. All right, I think Elvis talked about this a little bit. If you have any records that don't join, you'll get this. If you have no matches, you'll see these nulls in your table. That's the way ArcGIS handles it. It's also the way lots of other software programs handle that. Let's see what this says. It's not. I thought it was warning me of something, but it's not. Okay. So if we, for example, if we joined, if we had a table that had all the states in the United States and it even included Puerto Rico, and we joined it with another table that had state information, it might give us some null data for that area in Puerto Rico because it didn't exist in both tables. Okay, so now on to spatial joins. So spatial joins are really doing the same thing, but instead of saying, does this field equal this field, what we're going to do is say, does this spatial relationship exist in this table and in this table? Like, is there a spatial relationship between these two tables? So when we do a spatial join, we're always concerned about the spatial information, the geometry, the points, lines, or polygons in each table. So we're always asking a spatial question when we do a spatial join. That spatial question might be, so if the destination table is counties and the source table is tornadoes, we might be asking, how many tornadoes in every county? What type of relationship is that?
That's a numerical.
It's a one-to-many, like in cardinality. And you're right, we need to do some numerical summary of the tornadoes, count the tornadoes, or find out the average intensity of the tornadoes. We'll have to collapse them down to do that. Now, if we were to do one where we're joining, we already did this example, and we already talked about this example. We're joining cities, and we're going to join state information to those cities. What type of relationship is that?
Many to one.
Many to one, right? And so if we're doing a many to one, we're going to get repeat rows in our table, which is fine. It's just, and we do a spatial join, then we're going to get many. We're going to get that. Now, if it's one to one, which in spatial joins doesn't happen as often because it's hard to guarantee that there's always one, then we can just go row to row.
Can you put like back to the tornadoes? Each tornado have a period of time. So how many tornadoes in 1 year? You could join the time, maybe a year. How many tornadoes with that particular county? So that.
Yeah.
This is the same attribute table, right? But you want to join it by year.
Right.
And you can determine how many hurricanes or tornadoes in 1 year. Would that be a one-to-one join if you do not use it?
No, because every county could have more than one tornado.
Okay.
So even some counties will have no tornadoes in a year. Some will have one, exactly one, and some may have. It's highly unlikely that there's not a county somewhere that didn't have two tornadoes in a year. But
they will come up with a.
Even if that did happen, it still technically wouldn't be a one-to-one join because of the possibility that there could be more than one.
So what kind of join would it be?
A one-to-one join?
What could it be if I injected a time period and like say all counties don't have tornado? Would it just come back with a null?
Yeah. Yep. It's the same as a regular table join. If there's no county that has a relationship with a tornado, then if there's a county that does not have a relationship with the tornado, it'll have nulls for the tornado fields.
Okay.
Because that join didn't exist. That relationship didn't exist. So let's see. So oftentimes you can answer the very same questions you can with overlays or with other proximity tools. For example, if we went back to ArcGIS here and I ran the spatial join tool, so I got spatial join tool, and I'm going to the ArcGIS uses slightly different terminology than the kind of accepted terminology that's accepted general terminology. So here we're using the terms join features and target features instead of source and destination. So the join is the source and the target is the definition, the destination. I think target and destination sound close enough that you can try to remember that. Target and destination are the same word. They're the ones getting the attributes, receiving the attributes. Join is the one giving the attributes. Okay? So if we wanted to ask the same question that we asked earlier, we could join the target features being the counties, the U.S. counties, and we could join the Major League Baseball points to the counties. In this case, it's going to be we're going to join the join operation. We can do one-to-one or one-to-many. In this case, it's going to be one-to-one because every county is going to only get the attributes of one Major League Baseball team. Okay, because we're gonna do the exact same thing in a different way. So what we'll do is we'll say that the match operation is going to be the there's not a I thought there was, but there's not a nearest. Oh, it does. Okay, I'm sorry. I could have sworn it was there. So yes, closest. Where'd you say it was?
The very bottom.
Yes, closest, and closest geodesic. So that's actually the one we ran. So these are the attributes it's going to get, and if it's one-to-one, we can select that we just want all the same attributes, and then we select the match option. In other words, this is the spatial relationship. We want the closest one using the geodetic distance. And we'll just come up with a new field name called closest geo. And then we can run this. Running a spatial join. Now this is since we've already ran the near tool, there's going to be some repeats, but here's the output, and the output is now going to contain all of the information from the original data set. So instead of just getting the FID, we also actually get the team. Symbolize on the team.
This way is the best way to do it if you need all that extra info along with it.
Yeah.
Okay.
Yep. Join count. And we've got team. So now we got all the teams names listed.
You said team.
Yep. Now
It looks exactly the same.
it looks exactly the same. The output is the same. That was the equivalent way of doing the same, running the same tool. Exactly. Now we could do a spatial join that would be a one-to-many relationship using the same exact information. We have Major League Baseball. No, sorry, we have what are they saying? Counties as the target features, and then we have Major League Baseball points as the join features. But now let's select one-to-many. And once we do that, you'll see that the match options are a little different. I mean, it's hard to see. There's still several ones, several of the same. But let's do, because this one will be more interesting, let's do within a distance geodesic, and specify a search radius of, I'm going to change this to miles, and change this to 200, maybe 500. Okay. So now I've done a one-to-many relationship. And this is where this field map really becomes important. Because now that it's a one-to-many relationship, what has to happen when they merge?
Some kind of summation.
Some kind of summation. So this merge rule is the type of summation that's going to happen. All right? So if we want most of these things, like the team name, think about what kind of summation could you have with team name? I mean, does minimum and maximum doesn't even really mean much. Let's see, capacity. They have minimum maximum count last first. Oh, sorry, capacity. Capacity. There we go. See, capacity is a numeric value, right? You see how there's several different options that are different when it's a numeric value. You can summarize the capacity that's the capacity of the stadium. I'm going to choose that. Stadium capacity, yep. All right, now I'm going to run this. And there's our output. And I can symbolize our output based on a few new symbols. Let's go to graduated colors, or a few new outputs. So look, I can do join count and change the number of classes to 5. No. I said 500 miles, right? It's weird that these counties didn't get join count 1. They should have gotten more than 1. Let me look at my geoprocessing again here. One to many within a geodesic distance 500 miles. That should work. Okay. So this actually got me last year again too. So for some reason, to actually do this relationship, even though it is a one-to-many relationship, ArcGIS calls the collapsing in of all the data. It for some reason that I think is really confusing. The one-to-many relationship is what they call a one-to-one relationship in their terminology, and I'll explain how I know that. Okay, so look, we've got this one-to-one relationship, but we chose one-to-many, right? Look at how many counties there are in the original data set. How many counties are there in the United States? You guys know? There's a little over 3,000. See, 3,108 counties, right? After we did the spatial join, now look, there are, no, not this spatial join right here. That was the first spatial join here. So after we did the spatial join that was one-to-one and we used within a distance of, now we got 20,876 counties. And so when we click on any of these counties, we're actually getting 11 counties. In other words, there are 11 records right there. That means that there are 11 records. There are 11 counties all stacked up on top of each other because there are 11 counties that are within 500 miles from a baseball stadium. There are 11 counties that are 500 meters, and it's having a separate baseball stadium for each county. So the typical way to refer to that type of join is actually a many to one relationship, not a one to many, because the the destination table, the target table, should only have the number of records on the left side, but they're reversing what they call it. So to do what we actually wanted to do there, we should select a 1 to 1 and run it. And now, once it finishes running, we will have the information we want. So we can symbolize this using graduated colors and join count. Yep, that's right. So let's zoom back out.
Would the county count be accurate then?
Now the count. So yeah, that would be 11. That's the correct number of county. What? Sorry. Oh, you're asking this. Yes. Yeah, so now if I open up this attribute table, I'll only get 3,108 counties, which is the correct number of counties. Okay. Now the colors on here represent the number of baseball teams within 500 miles of those counties. So you can see in this area there are more baseball teams within 500 miles. Okay. See that?
Based on the rest of the United States?
Yeah, relative to the rest of the United States. If I click on one of these and I go to join count, it says 15. So that means for that county, which was Washington County, Ohio, there are 15 Major League Baseball teams within 500 miles. If I click on, let's say, this county right here, that is Reynolds County, Missouri, and there are 8 Major League Baseball teams within 500 miles of that area. Okay. Yeah, that's weird. That little county right there only has 2. It's probably this one and that one, and I would imagine, and this one maybe is just outside of 500 miles out. Okay.
So from what point does it measure that 500 miles? From the edge of the polygon?
Yes, from the edge of the polygon.
All sides it measures out.
Yes.
Okay.
So yeah, and you can read it. You could read it like if you actually had that question and you didn't know the answer, it would be included in the. It's included in the help.
Okay.
And the reason why you asked that question because if you love baseball, you probably want to be in an area that you can.
Yeah, for this particular question, it might not have a lot of relevance, but like.
If you're house hunting in an area that's close to baseball stadium.
Right. Yeah. I mean, or you could use this as like if you thought that, I mean, this is again probably not real, but if you thought that people that were closer to Major League Baseball stadiums or Major League Baseball teams on the whole had some other variable that you wanted to investigate, like maybe
Eating hot dogs.
yeah, eating hot dog. They're bigger hot dog fans. So if you had data that showed how many hot dogs people ate. Now that'd be a pretty dubious relationship, right? Like just because you live you shouldn't necessarily imply that just because you live closer to a Major League Baseball stadium or you're closer to more teams that you're more of a hot dog eater. But yeah, you could do all sorts of crazy statistical analysis.
Well, it could
with
be
that.
like a regional, like the Northeast has more hot dog fans because they have that culture around baseball because of
Right.
more stadiums.
Yeah, something like that. Yeah. I mean that's probably be more of a human interest type of a question, but something that you could.
But sometimes people request information and you need to come up with.
Oh yeah.
What you just came up with to make them to make a decision. Well, I want to go there. I want to put a business in that area. Might not be that, but whatever you trying to find
Yeah,
out.
hot dogs in Louisiana will probably do good right in Ohio.
Yeah, so we have and definitely, like insurance company could ask it. So here I've dragged on the hail points. Now there are tons of hail points, right? But let's look at
Least amount of hail.
yeah. So if we want to ask which counties get the most hailstorms, we could go back into the tools, spatial join. spatial join. The target features are going to be the counties again. U.S. counties. Oops, I'll just do the drop down. U.S. counties. And we're going to do the hail points as the join features. And our output, I'm going to name this something a little bit better. I'll call it U.S. county hail. And one thing that aggregation does in a real sense is it gives us a better idea. Looking at this map, it's really hard to see any patterns. Okay, but let's leave this on 1-to-1 because remember that's actually going to collapse them down to summarize them. Otherwise, we're basically going to multiply the two tables together. It's going to create one record for every unique pair of county hail point combinations. So we'll get tons
like a union, how it makes one a different.
Yeah, similar to that.
Every pair.
So now we're just going to do intersect. So it has to actually touch. So the hail point actually has to touch. Let's do contains because it's the same, really very similar, but I think that it captures better what we're talking about. No, wait. So let's see if that contains the feature and the join feature will be matched if a target feature contains the item. Yes, that's what we want. So the target feature contains the join feature, it'll be matched. And so we're just going to do the join. We don't have to really mess with any of this stuff. We'll just run this and we'll get the join count. Look at this loss. So there's a loss field, and so that is the loss field is the amount of damage that hailstorm caused. So one thing we could do is get the sum of all of the damage that all of the things. So instead of just getting the count, how many hailstorms there were, did they actually cause a lot of damage? Might be another good question. So I'm just going to run this, and this is going to take a few minutes. So
is that based on as far as money wise or just?
Yes, the loss is based on money. So now it ran. I don't know why it ran so fast. Let me turn off the hail points. It ran. Hopefully it actually didn't just crap out. Sometimes ArcGIS does that. Let's look and see if we can symbolize this. We're going to symbolize this based on not unique values. Graduated colors. First we'll do join count. So look at this. Doesn't that provide a fair bit more information than this? Like that versus that. I mean, it's hard to tell that there are actually more points right here, right? Than there are over here. That's one of the things aggregation does for you. Is it kind of helps you see. It helps you see more patterns. Now, somebody could argue that as your counties get bigger, you're going to see more points, right? Just because a bigger county covers a bigger area. And I think that's what is actually, I should sit down here. I think that's actually what's happening here in Arizona. Arizona has very large counties, as does Southern Nevada. Now, if we look at this, hail points, those areas appear to have a few more points than surrounding areas, but look at how dense this area is versus this. See that? And these are very, very light. So the number of storms, the number of hailstorms, this is where I grew up, right here in Orange County. See how it says the number of storms was only 9. And the number of storms in, let's say, Nye County, Nevada, was 81. Well, 9, if we take that 9 and we kind of, how many Orange counties would fit in Nye County, Nevada? Or Clark, that's Clark, sorry. Nye is up here somewhere, I guess. Okay. There's Nye. Okay. That's Clark County, Nevada. How many Orange counties would fit in Clark County, Nevada, do you think? Just eyeball it.
Like 7.
Maybe 7. So what's 7 times 9?
42.
42. So we're getting a little closer to that number, but we don't know exactly. So how could we kind of compensate for the different sizes of counties in the United States? What are some ways we could do that?
Either per square foot instead of.
Yeah, we could create a new field. Now we have all this data in there. We could create a new field called Hale P area. Just making that up. And then change that into a floating point. Make it a double. And then hit save up here.
Wait, so how do you get that edit?
So you go to how do I get back though? Click here. Okay.
Are you in the right attribute table?
No, I wasn't even in the right attribute table. Okay. So if I go open up the correct attribute table, I mean it doesn't really matter that I added to that. I hit add. I don't actually like using this tool. I think it's cheating because it's not using the toolbox tool, but I do it sometimes. So Hale P area, and then change this to double, and then hit save. By default it's long. I'm making it a double. And then
Did it automatically have that drop down in? Oh, there.
yeah, I double click on it. Now how to get back?
Numeric.
I'm just going to close it and open it back up. Yeah, it's going to be numeric. So now I've got this new field called Hale P area. It's full of, so how would I calculate a new value into that field? Like what do I do here? Because what I want to get is the number of hailstorms per area. So what would I do? I need to change any of this stuff?
How did you get back? Sorry.
I just closed it and opened it again.
Oh, okay. After you save.
Yeah, press save.
Isn't there a count per county?
Yes, there's a count per county. So that was the join count. And then I divide that by what?
Count per county.
What do I divide that by?
Would you divide
You guys have probably already said the answer on up in Hattiesburg.
the number county?
The area, right? Why does that make sense? The number of tornado, or sorry, not tornadoes. The number of hailstorms per area.
Per area.
So I'm going to run that and see if the pattern's any different. So now I'm going to re-symbolize based on that. So instead of choosing the join count, I'm going to choose the area weighted join count basically. Now I get that.
You did shape area.
Yeah, shape area.
And then
One of the things about these type of maps, for those of you who are in cartography, is one thing I like to do, if it's a continuous map like this, is to remove the boundaries between the it's a quick way to do that now in the new one. Maybe you could just go like this in ArcGIS Pro. Oh, outline width. No, it doesn't do anything. Maybe if I go back to single symbol and remove the outline, and then go back to graduated colors. Nope.
did you use join count divided by the area?
Yeah, well, I did join count divided by the area. Yep, it's this one. And I could change the number of classes to like 10. Let's see if that makes any difference. That doesn't look really different. Let's do this, some other color scheme. Ten doesn't really seem to help. Let's do 6. 6 or 7 classes is usually the best. And I'm gonna do quantiles because you'll get more variation there. Maybe not quantiles. Anyway, I guess quantiles. So now those counties in Arizona really don't stick out anymore because they aren't really different than their neighbors. Okay. I really would like to remove the boundaries. Apply to outline. Oh, there we go.
You get the density of the.
Yes, I just made the outline the same color. I don't like the outlines in these type of maps. I mean, sometimes they're cool, but anyway, what were we gonna say?
I was saying the darkness of those things. Is there a greater density of a hailstone because of the color you pick, or does it have a relationship to them? You know what I'm saying? You got darker blues.
The darkest blues are the more hailstorms per area.
Right.
Yep. Now, if I wanted to just do total loss, remember I made C loss the total, so I could just choose. Sorry, not C loss, loss. So I could just choose loss. So this is actually loss by county, the total loss by county. And it is interesting that there are some that really stick out now. So you're like wondering, like maybe a hailstorm affected a big city, like Las Vegas is in this city.
Right.
So, you know, maybe there was areas that really weren't prepared for a hailstorm, and even though there was only one hailstorm maybe there, or let's see how many there were. There were actually 81 hailstorms there, but maybe those hailstorms, since they happen so infrequently, they really were affected. Whereas in some of these counties, there may actually be no people or very few people, and it just pummeled those counties really, really bad, but there was only like 10 homes that were affected by the storms, and so the loss wasn't really high. See what I'm saying?
Right. It depends on what people claim in
Right.
those areas might be.
Yeah.
Dollar area.
Because it's loss. Yep. We've got magnitude of the things. So we've answered a few questions using this tool. Okay.
Well, space joint create a new field, to put the data in.
The spatial join will add as many of the fields as you want, and then you have to specify if you want them to be aggregated and how you want them to be aggregated. So the question was, does spatial join create a new field? Yeah, so let's go back to spatial join. So when we say that we want to join U.S. counties, hail points to U.S. counties, these are all the attribute tables. All the attributes that are going to get stuck on there. And we can go in here and say, oh, I don't want this attribute to get joined in. I don't want this one. I don't want that one. I don't want that one. I don't want all these attributes in there. That's possible to do. You can say, I only want certain fields joined. I don't want these joined. Okay? And then you can actually go in and say, I want to get, instead of getting the loss, I want to get the loss of the first record encountered. I want to actually get the total loss, or I want to get the minimum loss that occurred, or the maximum loss that occurred. So the trick here is to be able to transform your question into and answer it using all of these possibilities that you have. The things that you can control are which features are getting the records, which features are giving the records, where you're going to store the output, how you're going to store the relationships, and then which fields are coming over and how you're going to summarize those fields if there has to be any aggregation that happens. And then finally, the type of spatial relationship that you're trying to model, trying to find. Okay. And search radius doesn't really apply unless you're doing, something like within a distance. Then you specify the distance right there. Okay. All right. So just like in a table join where you're combining two tables based on a common field, a spatial join is combining two different layers based on a common location. And so that spatial relationship can be defined in more ways than just, are they in the exact same place? So in ArcGIS, spatial joins create a new data file, a permanent data file. Now, not every software is like that, but in ArcGIS, spatial joins are never virtual like they are, like table joins can be. Spatial joins are always permanent. They create a new file. So there are software packages like Oracle Spatial and lots of the enterprise databases that will do a virtual spatial join. In other words, the spatial join only exists for the moment where you're looking at the data, and if you close the software package, you can actually save the virtual spatial join, but it doesn't save the spatial join out onto paper. Onto disk.
What would be the purpose for? Is that good or bad to?
Well, if it was a very complicated spatial join and it took a few minutes to run, like our Hales did, it took like a minute to run, right? If it was virtual, every time the software opened back up, it would have to redo that spatial join.
Okay.
And it would store it in memory, so that it would also be using some memory resources. So the the nice thing about it is it doesn't store any data on disk. Also, the other nice thing about it is if your data is continually updating, like our Hale data set, if it was continually being updated, every time we open the software, if it was a virtual spatial join, and if it redid the join, it would include those new records that just happened. Like if a hailstorm happened today, we open it up tomorrow, and it would include that data. So there are some.
If it stored it.
That's if it's doing a virtual spatial join. If it saved it out, it's a snapshot in time. It's only that particular record for that day.
Okay, well, when you design it so that, so you're saying that if it's virtual, it's going to redo everything you did and just add what's currently happening now?
Because every time you open the software, it redoes the join.
Oh, okay. Based on the information that's where it's pulling it from.
Right, because it only saves all this information.
Okay.
It saves how the join was done rather than saving the result of the join.
So how do you have a data set that automatically updates like that? Is it?
Well, there's lots of ways that happens. Sometimes it's actually, somebody's responsible for actually physically updating it every day.
So can you basically do a Python program to pull from the national data network?
Exactly.
Automatically kick in and you ain't even have to do anything.
Yep, you can do that. All right. Sometimes it's kind of a new term that I've seen more often in recent time periods. Sometimes spatial joining is referred to as enriching. We're going to enrich a data layer by adding data from another layer. You actually see this terminology on ArcGIS Online. So in ArcGIS Online, there's the ability to enrich data. Let's see if I can pull that up real quick. I didn't plan to do that as an example, but ArcGIS Online. I don't know if I. So you guys should all be able to log into ArcGIS Online if you want to, based on the ability to log into ArcGIS Pro. But under analysis here, we actually have this data enrichment. So enriched layer, we'd have to add some data here, but so we want to choose ways to enrich the data here. There's actually a fair bit of ways there, but
You mean pulling from different sources?
Right.
live, and add it to your database?
yeah, we'd have to add. Let's see if I have any data. I don't know if this is. Here's my sum points. So I have some points that I made earlier. See all my points? They're out in the ocean. And here's wildfire locations that I made some other time. And I can go to data enrichment, enrich layer. I'm going to enrich some points, and I can say how I want to. So none of these really make sense here with this particular data, but
Enriching, what do you call enriching?
what's that?
What do you call enriching?
Enriching means it's basically the same thing as spatial join. It's adding some attributes to one layer based on their proximity or their overlap of another layer. Does that make sense?
Enriching is something you didn't do, but it's actually out there. You just updated more additional attributes to that particular spatial information.
Yeah, there are a number of tools here that are basically doing spatial joins. They're just not telling you we're doing a spatial join. So summarize nearby is also doing a spatial join. Summarize within. So ArcGIS is very much geared toward people that didn't necessarily take a GIS class, but these tools are doing spatial join operations based on these spatial relationships. All right. Okay. I think we've covered this pretty well now, doing the different types. ArcGIS actually reverses the difference here. So we've got our one to many, many to one, but they're all still the same. Here are a few more examples. Oh, sorry, I skipped a concept here, but it's also on the next slide, and I noticed it. So one way to think about whether or not there's going to be more records is to think about whether the join is a simple join or a summarized join. A simple join means that the number of records is going to there's not going to be any summarization going on. And so a simple join means that that if it's a many to many relationship, you're going to get the number of records multiplied by each other. So, if these 5 data in the left side and the 5 data in the other side, if they all have the same spatial relationship, in other words, if the spatial relationship determines there's a match between these 5 and these 5, you get 25 records in the output. You're going to get every possible combination between the two. So that's what a simple join means. And when it's a one-to-one relationship, it doesn't really matter much because there's just one-to-one. But when it's a one-to-many, it'll create that sort of thing in the output. So here's some examples of a simple inside join where we do hospitals to counties. So which county is each hospital in? Okay. Right, so there's many hospitals in each county. There can be many. Notice there's a couple counties up here that don't have any hospitals. But that doesn't mean that it's not a many-to-one relationship. Or, sorry, one-to-many relationship. So we're taking the hospitals and we're joining the counties. And what's happening to the table? Is basically the output table all the counties or all the hospitals?
All the hospitals.
Yes, it's all the hospitals, and they have the attributes of the counties.
So that's a many to one or one to many?
So we would call that a one to many. One county to many hospitals. But it's a simple join because there's no summarization going on. Now, if we go the other way, the most common way is to think about that as a summarized one where we take many hospitals to one county. Now, ArcGIS refers to this still as a one-to-one relationship because these are getting compressed before they're getting joined, basically. So they're getting summarized, then joined. But technically, in the literature, this is a many-to-one relationship, but it's a summarized many-to-one relationship.
I thought that was a one-to-many was the one that you sometimes chose one-to-one instead. I'm just trying to make sure that I have them right in my head.
Yeah. So in the diagram earlier, this is a many-to-one, but in ArcGIS, you choose one-to-one to get this. That's what I'm trying to say.
And the question it says also tell you if math is involved. They summarize how many of them.
Yeah, you're summarizing them.
So that's
So that first one on the left, the counties, the hospitals, that wouldn't be all the hospital records, and like some hospitals might, there might be 4 hospitals in one county, so it all have Hancock County.
This one.
Yeah.
Yes, this one is this one is basically turns into a list of hospitals. This join turns into a list of counties with hospitals added.
Yeah.
Yeah.
So.
One county to many hospitals.
Okay. I must have wrote that down wrong, because on the beginning of this, we thought we said it was a many-to-one for the cities, and then have the state abbreviations into it.
You're talking about this slide? Oh, sorry. Way too far back. This one?
Yeah. I thought it was the many-to-one on the bottom left. That was you had Waveland, Bay St. Louis, and Pass that have Mississippi.
This one right here?
Mississippi, yeah.
Yeah, many-to-one. What did I just say this was?
You said that was one to many.
Okay.
So it's many-to-one?
It's many-to-one. Yeah, you're right.
Okay. I'm just making sure.
No, sorry. You're totally right. I was just reading it the wrong way. But the 2 is read this way. Many-to-one.
so it says.
I said it wrong the second time.
2 adds one piece of information. That above heading over the hospital. It said at the top, simple adds one piece of information.
Sorry, what did you say?
One piece of information. The simple tool adds one piece of information. That's the one over there to the left.
The summarized adds a summary of many pieces of information.
Well, the one on the left says simple adds one piece.
Adds one piece of information, right? Yep. So here is using distance. We could do attractions to hotels. Which attraction is closest to each hotel? That's adding one piece of information from one attraction to every hotel. And this is how many attractions are closest to each hotel. So attractions being combined with hotels. So that's where we'd have to do a summarize.
So the bottom 2, the one on the left would be a one-to-one, and the one on the right would be a many-to-many, right?
Right. Now, I'm going to tell you something. All 4 of these, if you were to do a spatial join, all 4 of these examples, you would choose the one-to-one on here. In here. You would choose this one-to-one. So in none of these examples are you actually choosing anything besides the one-to-one. You'd only be choosing the one-to-many on here if you want to not summarize the data, and you basically want to multiply the number of records. You want to take all of the records that match, and create a huge attribute table with any. It's not summarized, but it's actually adding lots of pieces of information. So you typically will not be choosing one-to-many here ever. The time that you would be doing this is if you were. This is what I was trying to get at, because this is really the same thing as this many-to-many that's up in the corner on this other slide. So they call it a one-to-many, but it is, our ESRI calls it a one-to-many, but it's this one that you're actually doing. It's this one that you're actually doing. Students to classes or stores to customers. You're taking things where there's potentially lots of records, and you're joining it with somewhere where there's potentially lots of records to join with, and you're amplifying the number of records. So anytime there's a spatial relationship, the output table will have a row. Any spatial relationship will create a new row in the output table.
And that is the one that's similar to the
Yes. Yeah.
many to many.
It's called one-to-many inside of ArcGIS, but I believe it's confusing.
Yeah.
So, just one more time to be clear. All 4 of these examples, you would choose one-to-one in ArcGIS. And these are the 4 most common types of spatial joins you would do. Did I provide an example of the many-to-many before? I mean, yeah, you had, like, let's say I had a bunch of people and I did have a spatial relationship. Like, I had people that were potential buyers of houses, and I wanted to join them to the schools that they were nearby. And for some reason, I wanted to create a separate record for each buyer school combination. That's why I would do the many-to-many or one-to-many in ArcGIS relationship. So it would create every combination there was. It would create it. All right. So here, well, I'm going to join each well point to a geological rock name of the polygon that it is inside of. So which well has the better pump potential? So in other words, I'm trying to get the geological rock name into every pump. So what type of join is that? Yeah, it would be a one-to-one, but which of these 4 is it?
Would it be, what is the question? What is it the distance?
Okay, let's do the source and the destination first. Which one's the destination? The wells are the destination, and the source is the rock type. Yep. Okay, so the type of join is actually this one. Okay. It's not. It is a one-to-one, but we're adding one piece to another. We're adding one set of information to another, and it just so happens that there'll only be one relationship. Okay. All right.
So if a well went through numerous types of rocks, it would still.
Yeah, like let's say instead of rocks, these represented. Well, yeah, like let's say there was a possibility that the rock layer was 3-dimensional, and so it had gravel deposits here, and then underneath it had some other layer. Then it could be a one-to-many.
How about the depth of the well? How different water is that now? Do they have a difference in selecting the well based on that?
Yeah, I mean, but that's not in this example. Yeah. All right, so let's look at this one. For all rivers, add the population of its intersecting counties. How do we do this in ArcGIS? So which one would be the source? And which one would be the destination? Rivers or counties? The target versus the join is another way to say that. Which one's the
The county is the destination.
Okay, we got 2 different answers down here. Rivers or counties? We got tiebreaker up in Hattiesburg.
Rivers.
The rivers is correct. Rivers is the target or the destination. So the other one that's the receiving one, because we're trying to add the county's information to the rivers data set. Okay. Exactly. All right. Well, I'll let you guys go through that. Let's take a break, and then we'll discuss the lab. So I'm going to stop the recording.